3, 2, 1.
Okay, hello, willkommen, bienvenue, konnichiwa. It's time for the Armist Inquisition yet again, episode 186 on Sunday, the 30th of May. I'm Armish Phil.
I'm Armish Matt.
And Armish Ben's on a diplomatic mission to Alderaan, I think, tonight.
Yeah.
Just two of us. But we've got Matt here from the Apocalypse YouTube channel. How we doing, Matt?
Pretty good. How you doing, guys?
Very well. Nice to see you. I've been soaking up your videos over the weekend. You've been researching the lost city of Atlantis. But before we get into that, I think you should probably maybe tell us a bit about your background and how on earth you ended up on this journey, going down this rabbit hole looking for Atlantis.
Oh yeah, that's a good question. My background really, I've been an engineer since 2005, so that's like 16 years now. I'm both electrical and mechanical. I've always been interested in things like the alternative sort of history movement, things pioneered by Graham Hancock and Randall Carlson, for example. Atlantis has always been interesting. That's the very taboo one that you're not allowed to talk about. You can't use the A word. But it was really, I was watching Randall Carlson's Cosmographia podcast and YouTube channel, and he did a series on Atlantis, and he suggested there was some evidence that the whole of the Azores Plateau might have been above sea level at the end of the Ice Age. And I thought to myself, well, if this is true, sort of a year before that podcast, there was a European agency who compiled a load of bathymetric data and turned it into one big giant European bathymetric map. So I thought, well, now's as good a time as any to try and look for it. And I basically used Plato's dialogues as a guide. And right at the center of the Azores Plateau, there's a feature that's identical in size to what Plato describes as the lost city of Atlantis. So that's how I got here, really.
Now, a lot of people, I wasn't familiar with this term bathymetric before I started watching your YouTube videos too. So explain what the bathymetric stuff is.
So bathymetric scanning is basically you get like a survey vessel, and behind it you tow a device that outputs usually something like sonar, and then you just scan the sea floor below it and you get a 3D image, and you can compile it with other bathymetric scans and create large maps from them basically. And they don't have the best resolution, but you can usually get enough detail to tell you where certain depths are and major features, and the shallower you are, the better the images are basically.
Right, so bathymetric or bathymetry, this is the technology that they use when they're doing surveys of the ocean floor.
Yeah, that's right. So they're usually, the surveys are usually done either for mineral or just for exploration of hazards and just for research purposes.
Right.
So,
okay.
Sorry, I was just going to say, so is it kind of like this resource, is it an open source kind of thing? You could use it for free, it's just on the internet and anybody can kind of access it?
That's right, yeah. So the European one, it's I think it's called EMOD net, something like that. And they've just compiled basically all of the bathymetric scans into an online browser. It's very much like Google Earth, basically.
That's cool. And how much of the ocean floor have you actually is on there?
So they've got most of the ocean floor on there, not in as much detail as they've got for Europe, but for basically any European territory is mapped in some detail. Right. Not some of it's much higher quality than others. Mm-hmm. I believe it's an ongoing project, and I know that there's some collaboration with other agencies going on at the moment where there's a mission where they're trying to do this on a global scale now rather than just in Europe. So that's a collaboration between various agencies.
Right. Okay.
You mentioned the Platonic dialogues of Timeas and the Critias. Maybe for people who aren't familiar, you should maybe run down where this story of Atlantis comes from, the story of Solon and Egypt and all that, and how
Yeah,
it
sure.
relates.
So basically, Plato is famous for writing a number of dialogues, and there's two of his dialogues which are the only sources that are attributed to Atlantis. So there's other dialogues and other stories potentially that could be talking about Atlantis, but they don't call it Atlantis. So Plato's ones are probably the most important, and he apparently got this story of Atlantis from Solon, and it featured in two of his dialogues. What's interesting, these dialogues aren't particularly focused on Atlantis, really. Their main objective really is to sort of glorify Athens more than anything else. So the amount of detail that Plato goes into regarding Atlantis, it almost doesn't make sense to go into that level of detail. So there are other people that have come along shortly after Plato's time, like Crantor. Crantor was born shortly after Plato died, and he eventually became the leader of the Platonic Academy. And he said that there were still pillars in Egypt at the time of Crantor's life that told the story of Atlantis. So it was true. And also we have Plutarch, and we still use Plutarch's biographies today to fill in gaps in history. And he also claimed that it was a true story.
And you mentioned there about how there's sort of what's not anonymous. What's the word? They sort of stick out a bit in Plato's dialogue. I mean, when you read it, do you think he's saying this? He's talking about Atlantis as if it's common knowledge, like other people in that era knew about it, or is he purposely relaying this information? Because I'm trying to get in the head of the people at that time, and we don't know what sources they had access to and whatnot. I'm just trying to think if you've tried to get into the mind of the author in that sense.
I'm not sure, to be honest. It's difficult because if we go back to Crantor again, I think Crantor seems to state that it was common knowledge to the Athenians. So it wasn't just going through Solon to Plato. It seemed to be a story that was familiar to other people of the time in Greece.
Yeah, it's a strange one. And one of the most striking things about the Plato's account is that he gives a date for the destruction of Atlantis.
Yeah, so the date's really important, because if we work it out backwards, I think it's supposed to be 9,600 years before the time of Solon, which if we add on our date today, that's 11,600 years ago, which is exactly when the Younger Dryas ended and we transitioned into the Holocene, which is the era that we live in now.
Right, so the Younger Dryas, we have talked about it a while ago. We had the Cosmic Tusk on, didn't we? George Howard, probably about a year ago. Mm-hmm. So for those who didn't hear that one, the Younger Dryas was this climactic epoch, if you like, of a couple of thousand years, which sort of is at the boundary, isn't it, between the Holocene period, which we're in now, and the previous ice-bound, ice-locked Ice Age.
Yeah, that's right. Basically, the last glacial maximum, so that's when the Ice Age was at its peak, when it was at the coldest, that was about 20 to 18,000 years ago. And it started to warm up. We started to come out of the Ice Age, and then something happened about 12,800 years ago, where it started to cool down again. And there's a growing body of evidence to suggest that it was something extraterrestrial, so either like a bolide or meteorite impact, or combination of impacts, or some people now think it could be something like a huge solar flare is the other alternative theory.
Yeah, that's Robert Schoch's theory, I think, isn't it? The solar flare.
I think so, yeah. I think that there are some similarities in some of the evidence. I think it's something to do with you find a certain amount of helium-3 in certain compounds in certain areas. I'm leaning more towards the impact hypothesis rather than the solar flare. But to be honest, as far as my Atlantis research is concerned, either's fine for me.
Yeah, because all you're looking for is the catalyst for the melting of the ice and the subsequent flooding.
Yeah, that's right. Yeah,
because that's what Plato tells us happens, isn't it, with Atlantis?
Yeah. So as far as the story goes, the Athenians were at war with the Atlanteans, and basically it doesn't give a time period. It kind of implies that very shortly after the war ends, there's a global cataclysm that kills off both the Athenians and the Atlanteans at the same time, and they're in two different places in the world.
Now, this is something curious, that the account says that the Atlanteans were at war with the Athenians. And if we think back to that time period, I mean, that's something that sort of doesn't gel in my head.
Yeah, I don't know how true that might be. That might just be Plato embellishing the story for the glory of the Athenians at the time.
Yeah, or Solon.
Or Solon, yeah. The reason I say that is because there are other stories that run very closely to the Atlantis story. They never call the place of creation Atlantis, because there's one that's very famous in particular. I know Graham Hancock made this one famous, but there's a number of inscriptions on the temple at Edfu, and they tell a story that's very similar to the Atlantis story. But it's basically a lot of the physical descriptions are the same, but again, it's glorifying their gods, whereas Plato's almost switched the story to glorify Athens.
Yeah, for his own audience, essentially.
Exactly. Yeah.
Yeah, and flood myths are ubiquitous. They're everywhere around the world. It's just a common theme in ancient civilizations and sort of oral traditions is that there have been catastrophic floods. The interesting thing about the Atlantis myth is that it's suggesting a very highly evolved civilization that was terminated by it, which is what really excites me and what I find interesting about Hancock's work as well.
Yeah, I think that even in the Stone Age, if you could develop if you had very developed mathematical skills, you'd be capable of doing a lot of things. You wouldn't necessarily need modern electronics. You wouldn't necessarily need to have even discovered or had the ability to mine metals. There's a lot you can do with stone. In certain ways, stone's a superior material to metal. It's just much harder to work it.
Yeah.
So the other evidence we've got for advanced civilization at that time period as well is the building of Gobekli Tepi, and although it was quite an advanced site, so Gobekli Tepi, for anyone who doesn't know, it's a place in Turkey. It's almost like Stonehenge but more advanced. So there's very, very detailed carvings there. They're high relief carvings, so that means the carvings protrude from the actual pillars. So that means you have to remove material to get the carvings to appear. So that's a very difficult thing to do. And if you make a mistake, you have to start again, basically.
Yeah. Well, there's a picture on one of your videos, and I think of the pillars, and I think it looks like a puma or a jaguar or something coming out of the rock. I mean, it's amazing. Yes,
that's a level of craftsmanship that you would think that belongs to a civilization rather than a hunter-gatherer group. And I think there's some new evidence now. They're suggesting that there actually was settlements at Gobekli Tepi, because they were suggesting it was just done by hunter-gatherers. But I think the tide is turning on that now.
They have to, because the whole everything that they've been taught and they've learned and they've passed on to the next generation of young archaeologists tells us that this can't be true. So the amount of evidence has to be overwhelming for them to accept, settled civilizations at that time period. They have to be dragged kicking and screaming.
Yes, yeah. It's I think there's a number of issues. I think it's healthy to be skeptical. You can't just believe what everybody says, because otherwise we just have infinite mythologies and we have people coming up with all sorts of nonsense, really. So it's healthy to be skeptical, but at the same time you've got to be open-minded, and you can't let your ego cloud the truth potentially. And I'm aware that my research is probably going to be quite controversial, and I'm critical of my own research. I'm skeptical of myself as well. I think one of the problems in academia is that people, their whole identity is based on their research, and if your research turns out to be false, it's it's almost like an ego death, isn't it? You have to. It's like mourning.
Yeah. Well, great. Again, going back to Graham Hancock, he talks about this with Egyptologists, doesn't he? He's had quite a few. I remember seeing the video of him. I think he was. I don't know exactly what was going on, but I think he was having a debate with. Is it Zahi Hawass?
That's the one. Yeah. I think that's quite famous. Yeah.
Yeah, chief Egyptologist at for Egypt. I think it's the Egyptian head of antiquities or something. And he stormed off in a huff, didn't he?
Yeah, it was. We all have our bad days, but that's on the internet forever now, isn't it? It's not going to go away.
No. So you heard from Randall Carlson about this potential location being in the Azores. So what was your first step? What did you do?
Basically, I looked up Plato's dialogues for myself. I remember reading them as a kid, and I just couldn't get through it at all. It was just none of it made any sense. So it was, I was a bit more patient as an adult to try and wade through it. But I was trying to take it more as a literal thing. I wasn't trying to bend any of the details, as it were. I was trying to almost bullet point things in there that could help lead me to Atlantis. So, like I previously said, I was using this bathymetry website. So the website that's got all of the underwater seafloor scans on it. And basically the first thing I thought to do is, well, Plato said it's at the center of this large island. And by the way, that the Azores Plateau is the only sort of sizable continental type crust in the whole of the Atlantic between Europe and the Americas. So that's really the only place it could be. So
what does that mean? What do you mean by continental crust?
Basically, when you look at plate boundaries, they normally form either oceanic crust or they form continental type crust. And oceanic crust is thinner, and continental crust is thicker. There's probably other physical differences as well, but what it means with continental crust is that it protrudes upwards, basically. So if you look at the Azores Plateau, it's now 2,000 meters below sea level today. But all of a sudden, it just, like all continental boundaries, it just falls off of this huge plateau. It's the same around Europe and the Americas, and it's just too deep to be exploring. There's no way it could have been above water, anything surrounding it. So if you're looking at oceanic crust, it's going to be far less likely that it was above water.
Right. So is the ocean? Because I'm an idiot. I don't know anything. Is the ocean generally a lot deeper than 2,000 feet?
So yeah, the plateau is 2,000 meters, and then
meters.
There's large parts of the Atlantic are something that about 4,000 meters, and there's other parts that are much deeper.
Wow.
There's in the Pacific, you've got the Mariana Trench as well, haven't you? Which is I don't know how deep that is. That's even deeper again.
Right. So you can tell from the bathymetry that this sort of area of the Azores it protrudes upwards a bit more than the general sort of ocean.
Yeah, that's right. So what I tried to do really is I went through Plato's dialogues, and he described the island of Atlantis being greater in extent than Asia and Libya put together. And that basically, in the context of the day, it doesn't mean what we in the West think of Asia as today. It's a small part of the Middle East, and Libya's a part of North Africa. So you're looking for something of that magnitude, maybe not necessarily the exact size. And the Azores Plateau has a surface area twice that of Great Britain. So that's a pretty big piece of continental type crust in the middle of the ocean.
Right. So it ties in roughly with Plato's description of the extent of Atlantis, the Azores Plateau. Now, one issue is I'm a big Randall Carlson fan, and I've heard him say a few times that during the last ice age, before the Younger Dryas, that sea levels were approximately 400 foot lower than today. I don't know. Now, we're talking 2,000 meters, aren't we, for the Azores? So there must be something else going on here.
Yes. So the global accepted sea level rise since the last glacial maximum is about 400 feet. And meat, 400 feet. Into,
have you had a barbecue today?
No, I've had a haggis. So
I won't call that meat.
But yeah, it's going off on a bit of a tangent there. But yeah, basically 400 feet, and it basically ranges around the world from about 120 to 140 meters.
Right.
So what I've tried to do is I've tried to look up papers that could back up or back a case for the Azores Plateau being at least 2,000 meters higher than it is now. If you've watched Randall Carlson, you'll know he's already presented some older papers of core samples that were taken along the Mid-Atlantic Ridge, but I was actually trying to look for a mechanism. So that the core sample suggests there's beach sand in places that it shouldn't be. It's too deep. So I spent quite some time looking through papers written by actual geologists. I'm not a geologist, so I'm holding my hands up now to that. So there was one paper in particular, and they've got a hypothesis that suggests that the Azores hotspot. So we should probably say that the Azores Plateau is quite unique. It's a triple junction. So that what it means is there's 3 continental plates in that same area. And one of the unique things about it is it's also divergent. All 3 are moving away from each other.
Right. Yeah, this goes back to like Pangea, doesn't it?
It does, yeah. So the other interesting thing about the Azores is that if you reverse Pangea, if you looked at the world in a spaceship and hit rewind and went back 200 million years, everything went backwards. The center of Pangea, where it splits up, is the Azores triple junction.
That's weird.
Yeah.
And a great place for an ancient alien civilization to develop. It is weird. So this is the only place. Is this the only place on the world where you have this meeting? It must be then.
I think there are other triple junctions. Right. Like I said, I'm not a geologist, so I'm not aware of everything. But it looks like where the Azores triple junction is, it hasn't moved a lot over the last few million years. You don't see the hotspot tracks you see in other regions. So if you look at somewhere like Idaho, you can see where the volcanoes have moved over the hotspots over just a few million years. You see these tracts of land where the hotspots have passed over just a short period of time. And the Azores Plateau over the last 20 million years, it's split apart a little, but it's not really moved over that spot. Something I found out recently, someone's pointed out to me that there's something called an LLSVP below the Azores hotspot. So it's some sort of, when you measure, when you take tomographic measurements, so I think you're looking at seismic scans through the Earth now. I think you just use, to do that, you obviously can't ring the Earth. You wait for an earthquake to happen, basically, and you try and analyze the data. Right. But there's regions of low velocity, so it means the waves are traveling through this region quite slowly. I think one of the most accepted theories for this is the impact that caused the moon to form. So if we're really going off on a tangent now, but
sorry.
Most people are probably aware that there's a theory for how the moon was formed. So the Earth was smaller a long time ago, billions of years ago, and a Mars-sized planet likely hit the Earth, and that became part of Earth, and a small part of the Earth flew off and formed the moon, basically. And there's evidence that this planet was denser than Earth, and it's been spread over a couple of regions, but it's not spread evenly. And one of these regions is directly under the Azores hotspot. And because it's denser, we can probably assume that it's got quite a lot of radioactive material in it. That could explain why the Azores hotspot's there.
Wow. That's mind-blowing. So there's something going on like below the crust, where the Azores is. Yeah,
and this other paper. So we're going back to where I started from with this other paper that I read. They were suggesting there's periodic activity in the Azores hotspot. So this is between every 5 and 7 million years. It comes out of this low activity period, and it's so active that it causes the crust to triple in thickness. So this, you can. So the crust is more buoyant than the material underneath. So this could partly explain why the Azores hotspot might have been above water. And also, you're going to have significantly higher pressures underneath. So you've got an upwelling of pressure, and you've also got a thickening crustal material as well.
So the ocean floor would effectively kind of rise up and down over millions of years, essentially.
Yes, that's right. And because the Azores hotspot is on a triple divergent junction, the plates aren't supporting each other. They're only supported by the material underneath.
Mm.
Oh right, yeah, they're not like sewn together, are they?
No.
So
no.
if you look at the Himalayas, for example, you've got plates that are, well, they're holding each other up because they're being pushed towards each other. So they're not fully supported by the material underneath.
Mm-hmm. Yeah, that's what I was gonna sort of compare it to, was the Himalayas and Everest and stuff. So, and that kind of motion, really. And the other thing as well is, to my mind, or something that's coming to my mind, is I'm sure I've sort of read or watched something where civilizations tend to form along sort of like tectonic plates where they kind of meet each other, because there tends to be aquifers, minerals and things like that are pushed up to the surface as well, essentially.
Yeah, that's definitely true. Even relatively, modern places, or places in our own country. If you look at Dartmoor, for example, there's all these settlements that follow what's called the Sticklepath fault line. So there's a granitic fault line that goes all the way across Devon. And you see the old settlements travel across this because it would have been good for farming, good for mineral extraction. Just like,
wow.
It's great for farming in the Azores because it's so rich in minerals.
Yeah.
This is like taking guns, germs, and steel to the extreme, isn't it? It's not just about the right kind of crops or the climate. Being near a plate tectonic, what do they call them, where they meet? Fault line, is it?
Fault line, yeah, I suppose. Is it?
Near a fault line's the ultimate leg up you need if you want to start a civilization. It's crazy. You talked about, or in your videos, and I've heard Randall Carlson talk about it as well, this idea of isostatic depression, where you've got, maybe this could play a part in the Azores. Maybe you should explain how that worked with the weight of the ice and whatnot.
Okay, so yeah, isostasy is when you have plates that are supported by the material underneath. So if you've got divergent plates, you have pure isostasy, where it's a balance between the weight on the mantle and the weight of the crust, basically. And if you were looking at top loading isostasy, if you had a glacier melting on some continental landmass, that weight would run off into the ocean. So you would see the continental part start to rise out. So the land masses would start to rise up from the ocean, and then you get a rise up relative to the ocean, and then you actually see the oceanic crust. So where the triple junction is would be a really good example. You would actually see an increase in weight there. So the actual sea floor is getting further and further below sea level.
Right. So rather than the continental crust being pressed down, it's the oceanic crust around it is getting this extra weight of water that's been locked up in the ice sheets above North America, pushing down on the oceanic crust. Is that the gist?
Yeah, basically, yeah. So you'll get a rebound on the land, and you'll get a depression in the sea as the weight is transferred from one region to another.
I heard Randall somewhere use a really interesting analogy. It's like taking your butt off a settee.
That's right.
And it springs up. The cushion springs up when you. So we've got all this weight in water tied up across North America. It's hard for us to wrap our heads around what would happen if there was. I mean, the key is we're relying on the Younger Dryas being a very fairly sudden, sharp melting of the ice to produce this effect, aren't we?
Obviously, you would have, if it melted slow, you'd still get top loading isostasy. It would have just happened over a much longer period of time. But what we see from a number of different studies. One of the most famous one is the Barbados sea level, where they've measured sea level changes in Barbados. I'm not sure why that region's particularly good. Maybe it's just a nice place to do research.
Probably.
But for some reason, you can get excellent data at Barbados on global sea level changes. And you see there's a couple of huge events. One of them is called Meltwater Pulse 1A, which happens after the last glacial maximum. And the one concerning the time period of Atlantis is Meltwater Pulse 1B. And you're seeing an unbelievably huge amount of water melting from, well, in particular, the North American continent. So obviously that's running off. The North American continent starts to rise out of the mantle, which is the Isostatic. And then that water then has to go somewhere. It's going into the ocean basins, and then the ocean floor is being driven into the mantle below. So you're getting a corresponding load change and a corresponding change in the continental heights.
Yeah, it's so difficult to. I mean, they must have to use really sophisticated computer models to even get close to explain how this happens. I heard Randall say like the ice sheet was maybe 2 miles thick, 2 miles tall over North America and Canada.
That's right. Yeah,
I mean, we just can't get our heads around it, can we?
Yeah, it's almost impossible to believe it, isn't it? Or to try and imagine it. But the evidence is there. We know it was there. We know it melted quickly. So there has to be a reason why it melted quickly. So this goes back to the first part was the Younger Dryas impact hypothesis. But what caused the Younger Dryas to end? Was that another impact? I think there's more research probably needs to be done on that part.
Yeah. Now, tell us about the structure you found with the bathymetry. I say structure loosely. I don't know if it's a structure or a natural phenomenon, but these rings that you've been looking at.
So, given the size of this thing, I think it's a natural phenomenon. So, in the center of the Azores Plateau, you've got these concentric rings, which correspond to the concentric rings that Plato describes in his dialogue. So Plato says there are, at the center of the island of Atlantis, there's the city, and the city is formed of 3 land masses surrounded by 3 canals of water, and he gives very, very specific dimensions for those. And he says that basically it equates to the outer canal as 27 stadia in diameter, and we know how big a stadia is. So it's about 185 meters is the most commonly used unit, and so that 27 gives us about 4,996 meters. And this concentric circle ring, that the outermost one, is 4,996 meters at the center of the plateau. So that corresponds to what Plato's talking about. It looks to be about 3 stadia in width as well. It looks like there's a lot of sediment in the region, so it's difficult to tell. But Plato says the outer canal is 3 stadia in width. And then this feature at the bottom, there's the next canal inside, and that one's 15 stadia in diameter, which is the same as what Plato described. So that's another match, and it looks about 2 stadia wide, which is also what Plato described. The only one that's really missing is the third central canal. There looks to be possibly a trace of it there, but you can see a lot of sediment in the bathymetric data. So it needs further investigation, basically. And this is what I'm trying to put a case together for. Really, my videos are, I'm hoping someone, maybe James Cameron will watch it one day, and we'll find out. We'll find out on the news. He's been out in the Azores making some movie. I don't know, Terminator Azores or something like that. And, I mean, they can't get any worse at this point, can they? So
No.
Why not?
I mean, it's pretty amazing to find anything, because we're talking 12,000 years ago. You've all this disruption, like geological disruption. I mean, it's weird that you'd find any evidence in the bathymetry, to be honest, to me. I
think if it's a natural structure, it's going to survive for quite a long time. Yeah. I've since looked at the obviously you've seen what I've shown in my videos. I've since looked at some gravity maps of the region, and the gravity in that region is much higher. So
what?
it's
gravity.
So basically, if you're doing, if you use a gravity map, it will tell you what kind of rocks make up the region. So it's probably something like granite or basalt that make up that natural feature. So it's going to be quite durable.
Tough, right?
So that's why it's going to still be there for a long time. It will probably be there for millions and millions of more years if it is granite or basalt.
And another feature that you've tied to the Plato account is this. Is it called the Bory Hole? Yeah,
that's right. It's a rift valley basically, and if the whole of the Azores Plateau was above sea level during the Younger Dryas, then this rift valley could have provided an entryway, like a seaway, right into the middle of this giant landmass. Because what Plato says is he says that this island is greater than Libya and Asia combined, yet somehow this city, which is at the center, is right next to the sea, and that kind of didn't make any sense to me. And then I started looking at the bathymetric data of the Azores Plateau, and it kind of like, well, if this is the place he's describing, actually it does make sense now, because this huge rift valley could have actually led out all the way to the Atlantic Ocean, and it's only a short distance away from the center of the island.
Yeah, I mean, the other thing you said, I mean, it's roughly the concentric rings that you've found. They're roughly 5 kilometers across.
That's
in
correct.
Diameter. Yeah. Now, to me, I don't know. Do you think that's big enough, or is it too small for like a large? Or do we think maybe this was maybe the sort of the citadel, like the royal complex? I mean, what's your views on that?
So if Plato's story is correct, and we assume that there's a metropolis on this island, it's almost, I guess it's akin to London in the United Kingdom, isn't it? It's the capital city. So
right.
If you've got somewhere that's 5 kilometers across, you can fit a surprisingly large number of people in there, and then everyone else would live in the surrounding regions.
Yeah, it'd be interesting to just go on Google Maps and see what like the diameter of the city of London is. Not the M25, but the actual, like the heart of the city of London, see if it's, roughly comparable. But right, so the idea is that this is sort of maybe the political or administrative centre, and that the rest of the Azores, because how wide or how big is the Azores Plateau, did you say? About twice the size of the UK?
It's about twice the size of Great Britain, surface area-wise, yeah. It's a big space.
And you would presume if they were an advanced civilization that they would have outposts, probably in North, South America, in Africa and Europe.
This would be the ideal location, really, for having outposts, because if it's right in the middle of the Atlantic Ocean, you're probably 10-day sail to Europe, 10-day sail to America under the most favorable conditions.
Did they not have transporters like Star Trek?
I'm not... Well,
you're not going to be drawn on ancient aliens.
I'm not going to go down that rabbit hole.
Good for you.
I mean, it does. In Plato's account just says they have triremes, so they just have sailboats basically. I mean, we could talk aliens, but it's
it's nothing. There's more and more evidence. I mean, the sort of the Bering Land Bridge hypothesis for the populating of the Americas is really coming under some heavy flack over the last few years, and people are suggesting other methods by sea primarily of populating the Americas. I mean, I don't think it's unreasonable at all for there to be a civilization with navigation and seafaring 12,000 years ago.
I don't understand the argument for saying that there couldn't have been, because there's a lot of people that say you have to have a chronometer, which is basically just an accurate watch to be able to plot your position. But we could always measure latitude quite well. So as long as you just stuck to one latitude, and you took the relevant measurements to stay on that latitude, you'd get to where you wanted to eventually. You just wouldn't know how long it was going to take you to get there. I mean, a chronometer makes it a lot more convenient.
I mean, what's the name of that device, that Greek device they found? You watched that documentary on it, Mark?
Oh, God, yeah.
I watched it. Antikythera, is that it?
Yeah, Antikythera, that's the one.
Yeah.
I mean, you work in engineering.
Mm.
I mean, that device just looks incredible from concept to execution for the time period.
I wouldn't want to design that on a computer, let alone on papyrus. But yeah, it's just mathematics, really. It's advanced mathematics, and it's interesting. I saw a documentary on that one, and even with the misconceptions that they had in Greece, that it still works absolutely fine. So there were people that thought planets, everything seemed to revolve around our planet. And that made the Antikythera mechanism much more complicated than it needed to be. It could have actually been simpler, but they used all this. They figured out the maths of what the maths needed to be if everything revolved around our planet, and it still worked. So yeah, it was very complicated.
But the fabrication as well just blows my mind. Looking at these cogs and wheels, how precisely they were manufactured.
Sorry,
go on.
No, I was just going to say someone's trying to make it now someone's made
with copper chisels or something.
Yeah, basically. So someone's made it with today's technology, and then there's this PhD student is going to try and make it with.
That's a hell of a PhD.
Yeah,
Jesus Christ.
Going to try and make it with the technology that they think was available at the time.
That might be a very long PhD.
Yeah. Well, I think the other thing as well to mention is that the reason what I've found why archaeology in general and sort of universities and things, they don't sort of subscribe to these kinds of theories that don't have necessarily the evidence is, I think it's the term, I'm going to say this wrong, I think, but it's something called post and pre-processualism, I think is the word. So in archaeology generally, and I can't remember when this occurred. It's sometime in in the 20th century. There was basically fields of archaeology where people would, dig stuff up, and then they would build an entire civilization around the things that they found. Whereas, and I think that's pre-processualism, and then post-processualism is basically they won't say anything now unless there's actual physical evidence that they find that says that, yeah, people were sailing across the ocean 12,000 years ago, which is obviously going to be quite difficult to find, you would think, I suppose.
I think it's really the genetic evidence, isn't it? That I think South America in particular, they're suggesting there's traces of Australian Aboriginal DNA in certain tribes there, and you don't find that in populations that are there today or the remains of people that were there thousands of years ago. And it kind of implies that people have sailed across the Pacific.
Yeah. Well, that's the other thing, isn't it, about the people that sort of island hopped and all the way across the Pacific, the South Pacific, isn't it, I think? And that the distances that they achieved and did it, on those tiny little islands. But there you go.
Oh, but you don't forget, in the Pacific, you had the lost continent of Mu. You could just stop off there on your way.
I've not looked at that one yet.
That's your next job, Matt.
Yeah.
Go and find Mu for us.
I'll give it a go.
He doesn't look very confident.
It's supposed to be ginormous, Mu.
There's a lot of sunken land between like Australia and Papua New Guinea.
Okay.
Down towards Southeast Asia. I mean, there's probably parts of, you almost probably could have walked a lot of the way to Australia from Southeast Asia, and just either I probably wouldn't want to swim it with the sharks in that water, but you could just sail the last part, or even canoe the last part, I would imagine.
Really? Right. Okay.
I mean, I guess part of the problem you were saying before, and maybe Matt was saying about the archaeologists being reluctant to go down this road without finding certain levels of hard evidence. Now, it seems to me, if we're looking for a lost civilization pre-Younger Dryas, and we know that most civilizations tend to congregate by the seashore and by rivers and whatnot, that if we were to find any evidence, we're probably going to have to look underwater for it.
Yeah, I think that's probably the most logical thing. I mean, there's a number of places off the coast of India very large settlements that could date back to the end of the Ice Age. And obviously, like you say, everything does either seem to form, or civilizations tend to form either by riverways or by the coast. And I think they are starting to find these places now, but it's just so difficult to actually do any archaeology. Even 120 meters below sea level, it's difficult.
Yeah, and we still haven't got to grips with what's on the ground either. I mean, I've been not really following, but I've been sort of loosely following these sort of LiDAR surveys in South America, and they just keep cropping up. These ginormous cities and settlements that have been sort of swallowed up by the rainforest, and no one knew anything about them.
Mm-hmm.
Yeah, I mean, they're turning up all the time now. I believe even in Africa now, they're starting to find a number of old settlements, or potentially old settlements in the Congo. There's been a number of satellite images that suggest that there's organized patterns that could indicate that there was agriculture going on in parts of Africa before we thought it was actually happening.
Yeah. Now, just going to your YouTube channel, I think, have you got 5 videos up now?
I literally 5 minutes before this show started, I uploaded number 6.
Oh, right.
Yeah.
So what's the sort of latest development then? What's going on in the last video?
So in the latest video, well, there's been a couple of people that have contacted me on the Graham Hancock message board. So if you go to Graham Hancock's website, he's got a forum where anyone can just use an email address to set up an account, and you can have discussions on there. And there's some absolutely fantastic people on there with far more knowledge than me on actual ancient culture and ancient history. And there have been 2 people in particular who've contacted me. One of them's the author, Gary Osborn. And he's pointed a couple of things out to me that, firstly, that if you look at the Sphinx, or if you look from the perspective of the Sphinx during the summer solstice, at sunset, it points in the direction of the Azores. So what I've actually done in this latest video, it's worth a watch. There's some interesting coincidences. I went to a website called suncalc.org. So I was trying to work out the exact angle that the sun sets on the Giza Plateau from the perspective of the head of the Sphinx.
Right.
And it's a bit more difficult than you think, because the sun doesn't set at a level horizon. The Sphinx is situated downhill from the horizon. So I worked out it's about 0.86 degrees below the horizon is the head of the Sphinx. And that gives you a bearing that you can create a great circle arc with. And what I mean by a great circle is if you were to draw the shortest route between any 2 points on a sphere, that's a great circle. So it's just like if you were walking in a straight line in real life, that's a great circle. Whereas if you were to follow a latitude line, apart from the equator, if you followed any other line of latitude, you're not actually walking in a straight line to get there. So the great circle is the shortest route. So if you use the sun from the head of the Sphinx and you follow that bearing to give you or the initial bearing to give you a great circle, that takes you right into my location for Atlantis, which is a very strange coincidence. So
there's a lot of these, isn't there?
And yeah. You look at the distance, and it's exactly 5,556.6 kilometers. And why that's significant is because that's exactly 30,000 stadia. It's not 30,001. It's not 29,999. It's exactly 30,000. It's almost, yes, yeah. It's worth watching the video. I'm not doing it justice by talking about it. So this was pointed out to me. Well, the actual bearing was or the concept of finding this bearing was pointed out to me by Gary Osborn, and he also made a note to me about how the furthest structure from the head of the Sphinx on the Giza Plateau is the westernmost Queen's Pyramid. So that's the smaller of the 3 great pyramids. There's 3 smaller pyramids located south of those, and the furthest one from the Sphinx is exactly 1,080 meters. And it turns out
Sorry, go on.
Well, basically, it turns out that Gobekli Tepe, so could be related to the Giza Plateau, because Gobekli Tepe is exactly 1,000 times that distance. It's 1,080 kilometers. And I've taken that research a bit further in my video. And if you draw a line from the head of the Sphinx to the Great Pyramid, it perfectly reflects. You get a line that reflects the two vectors that you get from the Sphinx to this pyramid that's 1,080 meters away, and you reflect that vector based on that new line we've drawn between the Great Pyramid and the Sphinx. That reflection takes you up to Gobekli Tepe at exactly 1,000 times the distance, 1,080 kilometers. And then I've gone a step further than that. Now I've actually I've projected the latitude of the Sphinx out into the Atlantic Ocean, and I've projected the latitude of Gobekli Tepe out into the Atlantic Ocean. And it takes you to an island that would have been there at the start of the Holocene. So Gobekli Tepe is the same latitude of an island which is now called the Dolabarata Reef. It would have been the very easternmost island of the Azores archipelago. And then if you do the same thing with the Sphinx, if you project the latitude of the Sphinx out into the Atlantic Ocean, it takes you to the Great Meteor Sea Bank. And part of that, the westernmost part of that, likely could have been above sea level at the very start of the Holocene. And you can draw a line between those two places. And this is where this other chap comes in now. This chap called, he's a French retired engineer called Michel de Maria, and he's told me about a book he's reading, and it suggests that Stone Age peoples probably weren't actually taking angular measurements. They were just drawing right-angle triangles of different lengths. So that the most famous one is the 3-4-5 triangle, because the hypotenuse is an integer basically. So it's really easy to calculate. And we get this triangle, which is, if we project a 90-degree line out of the Dolabarata Reef, it takes you to the westernmost island of the Azores, which is Flores Island. And you can draw a triangle you can close that triangle between Flores and the Great Meteor Seamount, and that's exactly 1,080 kilometers, the same distance as the Gobekli Tepe distance.
Wow.
But more importantly, you can project from Flores Island. If you now follow if you look at the winter solstice sunrise, that projection, that great circle arc crosses over the arc. The great circle arc that comes from the Sphinx crosses over that great circle arc precisely over the location I've suggested is Atlantis. So again, another coincidence, or maybe not a coincidence.
Holy shit!
But the distance. So you know how I said that it's precisely 30,000 stadia to the Sphinx from my proposed location.
Yeah.
Well, to the Flores Island, where it overlooks towards Atlantis, that's exactly 1,000 stadia. It's not like 1,001 or 999 again. It's a very, very strange coincidence, and it possibly, they've chosen to place Gobekli Tepe and place the Sphinx where it is, to point the way back, is what I'm suggesting. Wow. I know it sounds absolutely insane, but it's more tangible if you watch the video.
No, I think there's a lot of things like this that kind of, so-called coincidences,
sacred geometry
and things like that, isn't it, associated with the pyramids and all kinds of ancient civilizations, really. And it points towards that kind of progenitor civilization, I suppose,
You mentioned, I got really excited when you mentioned 1080, because that's a sacred number.
That's right. Yeah.
That's why we have 1080p televisions.
Exactly. Yeah. the sacred screen. Yeah.
Yeah. But it's in meters. Now, meters is not an ancient unit of measurement, is it?
I think it could well be.
Or could it be?
Oh.
There's some evidence to suggest that the Egyptians were using the meter, and I think that there's two pieces of evidence. One of the supposed pyramidions that was likely to be on top of the pyramids was supposed to be exactly 1 meter high, but the the other strange thing is that the royal cubit is precisely
half a meter.
It's something. I think it's pi divided by 6 or something like that, and it gives you 0.5335 meters or something. So there's a pi meter relationship, but it certainly looks like there are precise meter measurements found in Egypt. But I guess it's a bit like us. Sometimes we use metric, sometimes we use imperial, and I'd imagine other cultures would probably be the same.
You got to use imperial. Man is the measure of all things.
Well, yeah, exactly.
Yeah. The cubits. So as far as I understand, the cubit is the elbow to the fingertip. Or 4, is it 4 or 5 palms? Hang on. 1, 2, 3, 4. Maybe it's 6. No, it's 6 palms, isn't it? And then the royal cubit has an extra palm. So it'd be 7 palms, I think.
Yeah,
Unless I'm talking smack. I don't know.
It sounds about right. I tend to remember numbers better than palms, to be honest. So.
Yeah.
Wow.
I'll try that. Next time I do a drawing for one of my clients, I'll do things in palms and royal cubits and see how long it takes for them to get back to me.
It's a very important message, though, because all these ancient civilizations, they used our bodies as a reference point for all the measurements. That's why we have a foot is the length of a foot. A mile is 1,000 paces. And it suggests, what I love about it is it suggests a relationship between us and even the celestial, because we know that there are relations and ratios at work with celestial mechanics, the earth and the moon and the sun and whatnot. Yeah,
I can't remember the exact rules, but planets can only be in certain places. So you get certain, it's a bit like harmonics, I guess, isn't it? If you get a planet in the wrong orbit, another planet will destabilize it. But you could argue there's this fractal system scaled down to smaller levels as well.
Yeah, people think it's such an amazing coincidence that the moon is just the right diameter to create a lunar eclipse, and the relationship between the sun, the earth, and moon. It's just a complete fluke that we happen to be here, the only sentient beings in the universe, and we happen to live on a planet where we have these relationships that create solar and lunar eclipses. And come on, have a think.
Yeah, there's just
something going on there.
There seems to be an endless stream of coincidences that happen to put everything just in our favor.
Yeah. And it helps when you're born on top of the the aquifer.
Yes.
That was something on one of your other videos, I think. What was that one where you drew the line across the globe between the four pillars? That was it.
So that was I was basically trying to link other stories that might relate back to Atlantis to other geological locations. So it's quite strange. You can find these volcanic hotspots at exactly 90 degrees around this great circle that goes around the world. I think there's obviously the Azores hotspot, and then the other one I picked out was Easter Island. Everyone knows where that is. That's 90 degrees around the world circumference. And then there was a hotspot in South Australia that it seems to be completely out of place. There's nothing else around it. It's just this strange volcano. I can't remember the name of that one. There's Aboriginal stories with regards to its creation, and you follow that same line round, and another 90 degrees around the world, you get a place called Mount Gurnar, which is in India, and it's a sacred place for both Jains and Hindus. And it kind of makes me wonder: do these hotspots have some kind of relation to the Earth's magnetic field? Because a magnetic field isn't always a perfect toroid. There's other things that can interfere with that. So you get lines of flux that are just slightly more deviant from the majority of the flux lines. I mean, we have 3 north poles that we can look at. For example, we've got the geographic North Pole, which has nothing to do with magnetism. It's just where the Earth spins. And then we have another North Pole, which is where your compass points to, which is the average point of them. And then there's another, I can't remember the exact terminology for it. There's a third North Pole, which is also a magnetic North Pole. that's the strongest of the poles, I believe. But then the one your compass points to is just the average of the poles.
And just going back to the 4 hotspots, Easter Island, India, are they fairly equidistant from each other?
Yeah, they seem to be equally spaced on this. If you draw like the Earth's circumference, which is about 40,000 kilometers, if you draw a great circle line, a 40,000 kilometer great circle line from where I'm saying Atlantis is through Easter Island, and you carry that line on, it takes you to this volcano in Australia, and then it takes you to Mount Gurnar in India, and they're all separated by about 10,000 kilometers or 90 degrees. It's not a perfect circle, but it's about as close as you're going to get.
That's amazing. And so if you sort of try and picture in your head, if you had X-ray vision and you could see through the oceans and the crust, that you'd have almost like 4 spokes coming up.
Or at some point, I think some of these places are no longer active. But why were these regions hotspots at 90 degrees away from each other? I do have a background in magnetics, and I know that there's things that influence lines of flux. So it could be the type of rock. So most rock, the magnetic permeability of a lot of sort of inert rocks isn't much different than free air. But if you've got a metallic content in the rock, it can change the magnetic permeability, so it can channel lines of magnetic flux. It could just literally be a geological phenomenon it's just not fully understood as of right now.
Well, Matt, my mind's blown.
Yeah, I enjoyed tonight.
Yeah, it's really fascinating. Really interesting research. Are you obsessed? Are you on the verge of an obsession here? Do we need to worry about an intervention?
You'd have to ask my girlfriend. And, I'm not going to let you talk to her. So, so that's yes. My answer.
Say yes, yeah. No, I love it, and I can't wait to check out the next video. I mean, what you planning with the channel? Are you just gonna keep going as far as you keep finding things, or are you looking to sort of do more collaborating and try and find more evidence? What are you sort of planning on the, because obviously, you're a busy guy, you've got a company to run full time, you're doing this on the side. I mean, have you thought that far ahead?
As far as the Atlantis videos are concerned, there's one I released 5 minutes before this podcast started. So that's video number 6. I've got a 7th one I'm making. That's regarding the Edfu texts, but also other ancient stories that seem to very strongly resemble the Edfu texts. And then after that, that's the majority of my Atlantis research done, to be honest. I'll probably do small update videos. I'll probably do a very small, like 1 or 2 minute long video regarding this LL SVP situation regarding the geology. So I'd like to move on to other things. So not just Atlantis.
Yeah.
But other potential ancient mysteries worth obsessing over.
Yeah,
brilliant. Well, sounds great. Thanks for coming, Matt. I've really enjoyed it, and we'll put the links, obviously, all the links in the descriptions for your channel, and you're on Twitter as well, aren't you?
Yeah, I'm on Twitter. Yeah, Twitter, YouTube, Odysee, or LBRY.
Yeah.
So yeah, you can find me in all of those places. If you just search for the word apocalypse on Odysee, I think I'm the top search on there now. So
cool.
That's the easiest way to find me.
Brilliant. Well, it's been great, and we'll look forward to watching the latest videos, and I hope everyone listening can check them out as well. Stay on the line for us for 1 minute while we play ourselves out, and we'll catch you on the flip side. Nice to see you, Matt.
Cheers.